All right, so back in chapter 5, looking at section 7, which is gases and chemical reactions, stoichiometry revisited. All right, we've seen this before, haven't we? All right, so again, stoichiometry, oftentimes we're going to be doing A plus B produces C, and let's say maybe 2B and 3C. Stoichiometry is, 1 mole of A is going to give me how many moles of C. This is what stoichiometry is. And so in order to do that, we've got to set up a ratio, right? Remember the ratio? Of course, it's going to be moles of C over moles of A, because the A's are going to have to cross off. And it looks like it's going to be 3 to 1. See a 1 right there? It's going to be 3 to 1. So that's going to give us 3 moles of C. I know you can do that by inspection, but the important point here is with stoichiometry, we're doing molar ratios. I don't have anything else I want to say about this. Let's go straight to a practice problem. I think we've got 2 practice problems to do here. Let's go straight to a practice problem. All right, so methanol can be synthesized according to the following reactions. Carbon monoxide, hydrogen gas, methanol. What volume in liters in hydrogen gas? Okay, so all right, so there's just a bunch of details here, and you've heard me say before that if we get these written down wrong in the wrong part of the paper, we don't know where they are, we don't know what they are, we're in big trouble. So I'm going to carefully set these problems up. Actually, I'm going to set them up all the same way. I'm going to typically call the first reactant A, and then B, and then C, and that'll just save me lots of grief, okay? So now I could just write my table right here where these would be my column headings, but I'm afraid that's going to get a little bit too busy for the viewer of the video, right? So I'm going to do A, B, and C. Okay? And I'm going to, looks like I've got, so my hydrogen gas is going to be right here. This is going to be my B. Measured at a temperature of that. All right, so it looks like I'm going to be doing an ideal gas again. PV, nRT. So, all right, yeah, I'm given this many grams of methanol. So I'll eventually, well, let's go ahead and fill this in. We'll pretend like we don't see ahead, okay? 355 Kelvin, that's going to be right here. 355 Kelvin, right? Because what volume in liters of hydrogen gas? Oh, that's the question right here. Once I fill in the box, I'm done, right? What volume of hydrogen gas is right there? Measured at a temperature of 55 is here, and a pressure of 738. So I don't have a lot of room here, so I'm going to convert 738 to atmosphere someplace else. Right? And this is going to give me, just a minute here, 738 divided by 760 is equal to 0.9711. 0.97. I'm going to say 105. Keep the extra digits for now. 0.97105. I'm just going to use everything as liter atmospheres and moles and kelvins here. That way I won't worry about that. I guess I can put atmospheres out here at the side. That's usually what I do, right? Okay, and then this is 0.08206. All right, and I don't know moles. As soon as I figure out moles, though, I'll be done. I'll just put volume in it, right? All right, but I do know the moles of methanol. Not yet, but almost. Let me go to blue and say that I know if I've got 35.7 grams of methanol, do you mind if I just call this C? Keep things simple. Grams of C. Grams of C per mole of C. This will give me moles of C, right? And so what is this is the reciprocal formula weight. So the formula weight of methanol is going to be 1 times carbon, which is 12.01, plus 4 times hydrogen, which is 1.008, plus 1 times oxygen, which is 16, which is going to be, 4.032 plus 12.01 plus 16. That looks like that's going to be, it's 20.032, 32.042 grams per mole of methanol, right? This was methanol. Agreed? So it's 32.042 grams of methanol per, okay? These grams cross off, and I'm left with that, which is exactly what I wanted. So it's 35.7 divided by 32.042 equals 1.1142 moles of carbon, or not carbon, sorry, methanol. 1.11416. I'm going to say 412 moles of carbon. Well, what I want to do now is I want to convert the moles of carbon to the moles of hydrogen, right? That's what I was looking for. Can I call it moles of B? You guys okay with that? Moles of B. I have moles of C though, right? So looks like I'm going to have to do the molar ratio. And this is the stoichiometry, by the way. Stoichio, stoi, oi, ki, o. Nice long Greek word. Anything with lots of I's and O's in it is always Greek. That's how I know I speak Greek. Because I just recognize words with lots of I's and O's in them, and I go, oh, that's Greek. And then I look it up, and I speak it. Alrighty. 1.1142. And then what's the molar ratio of B to C? Aha, 2 to 1. See it right there? 2 to 1. So I take this number and multiply it by 2 times 2 equals 2.2283. 2.2283 moles of B, which is exactly what I wanted. Look at that, 2.2283 moles. And now I'm ready to calculate V, right? PV is equal to nRT. V then is going to equal nRT over P, which is equal to 2.2283. I'm afraid I'm running low on space here, so I'm not going to put the units in. So it's a really good habit. I hope you do put them in. 206, 355. The reason I'm not worried about putting the units in notes is because I was so careful to get the right units in the beginning, right? Kelvins, liters, atmospheres, and moles. And this then is going to be 0.97105. And this is going to give me in liters. See, I know it's in liters because I was so careful. But if I had written all the units out there, you'd be able to cancel them out and tell. 2.2283 times 0.08206 times 355 divided by 0.97105 equals 66.85. 66.85 liters. Let's do sig figs now. There's 3 sig figs here in that number, 3 in that number, 3 in that number. It must be 3 here, right? So we're going to say that the volume is 66.9 liters. Look at that. What volume in hydrogen gas? 66.9 liters. I love that. You know, so I'm tempted to give myself a couple stars there, but you know what I'm going to do? I'm going to add something here for those of you who are watching still and not sleeping. I'm going to say this. Oh, look at that. Okay. All right, let's do another problem, and then we'll be done with this section. So the other problem, again, this is going to be stoichiometry. Using molar volume. That's the shortcut. All right. So I'm going to use the molar volume shortcut, even though I've already told you I'm against shortcuts. How many grams of water? Okay, I'm already lost. How many grams of water form when this? Okay, so this is STP, and this is my gas right here. So I'm going to use this A, B, and C, and you know what? I'm just going to use this as my column heading right here instead of rewriting it over here. So P, V, N, R, T. Okay, and it's STP. So pressure is 1 atmosphere. Temperature is 273 kelvins, right? And this is 0.082. Oh, you know what? I don't need that. It's the we're using the molar volume. So I'm going to put this to the side. If for some reason I get sideways with my molar volume, I'm going to come back and solve it like that. Let's go do a different color. And the molar volume is 22.4 liters, right? Remember that? Per mole, right? And in this case, it's of H2. Okay. Now what we're going to do is say that there's this many liters. I got moles in the bottom. You know, ultimately, we're going to need how many grams of water? We're going to need grams of C. Grams of C. And since it's stoichiometry, I know I'm going to be going through a molar ratio. So it's going to be moles of C per mole of what? A. Here's my stoichiometry, by the way. Stoichiometry. Okay. Moles of A per liter of A. Liter of A. This is it. I'm going to go back to red now. Wait. Oh. And color, sorry. Red. Okay. My liters of A is right here. 1.24. And this is just a given. It's a measurement. It's not a conversion. Right? This is my molar volume. (22.4 liters per mole). This is my stoichiometry, and it looks like it's 2 to 2. And my grams per mole of C. And I remember I just do this one so often. Do you mind if I not calculate that out? It's 18.02 per 1 grams of water per mole of water, right? Remember we did that? It's 1.0. I just said I wasn't going to do it. I'm doing it because I'm afraid that somebody's going to look at that and get afraid when it's not. So this is an old friend of ours. So this goes to 2.016 plus 16, which is 18.016, which I've got here is 18.02. All right, so we're almost done. 1.24. Uh-oh, lost my calculator. Just a second here. 1.24 times 1 times 2 times 18.02 divided by 22.4 divided by 2 divided by 1. And the answer comes to be 0.99753 blank blank blank. 0.99753 grams of water, right? Grams of water. So there was 3 sig figs here. And that's the only measurement I have here is 3 sig figs. So let's take this to 3 sig figs and we'll say it's 0.998 grams of water. And that is the answer. All right. Hope that's helpful. That's it for this